How old is our planet? The Earth is an astonishing 4.54 billion years old, a number so huge it's almost impossible to wrap our heads around. But how do we know this? It's all thanks to the incredible science of radiometric dating, a method that acts like a time machine, letting us peek into the deep past by measuring the decay of radioactive isotopes in ancient rocks and meteorites. One of the pioneers in this field was Clair Patterson. In 1956, he studied lead isotopes in meteorites and calculated the Earth's age at 4.55 billion years, giving us one of the first solid estimates. His groundbreaking work was published in the journal Geochimica et Cosmochimica Acta. That was a huge moment in science, turning bits of space rock into a window on Earth's beginnings. Since then, researchers have kept building on that foundation. Samuel A. Bowring and Ian S. Williams, for example, studied some of the oldest rocks on Earth, tiny zircon crystals from northwestern Canada. These crystals, dating back to 4.4 billion years ago, are like nature's time capsules, offering direct evidence of the Earth's early crust. Their fascinating study was published in Contributions to Mineralogy and Petrology. Then, in 2001, G.'s Brent Dalrymple pulled together decades of research to confirm the Earth's age at 4.54 billion years with amazing precision. His comprehensive synthesis was published in the book The Age of the Earth, a fantastic overview of the methods and evidence that have shaped our understanding. Before radiometric dating came along, people's guesses about the Earth's age were all over the place. Some thought it was just a few thousand years old, while others stretched it to hundreds of millions. But this method, especially using uranium lead decay and zircons, has given us a clear, consistent answer. That 4.54 billion years, give or take 50 million, is a testament to the power of scientific discovery. It's pretty awe-inspiring to think about our planet's epic journey, from molten chaos to the world we know today, all pieced together by these incredible studies. After its violent birth 4.54 billion years ago, Earth was a scorching, chaotic world, a seething ocean of molten rock constantly battered by asteroids. No land, no air, and certainly no water. But as the planet cooled, something remarkable happened. A crust began to form, and with it, the conditions for one of the most transformative events in Earth's history, the arrival of water. Scientists believe Earth's water came from two major sources. Some of it was released from deep within the planet as volcanic eruptions spewed massive amounts of water vapor into the atmosphere, which later condensed and fell as endless rains, slowly filling the first oceans. But Earth was also pummeled by icy comets and water-rich asteroids during a period known as the Late Heavy Bombardment, 4.1 to 3.8 billion years ago, bringing even more water from the far reaches of space. By 4.4 billion years ago, Earth's once fiery surface had cooled enough for liquid water to settle, forming vast, alien oceans, hot, acidic, and rich in minerals. These ancient waters, though unrecognizable compared to today's blue seas, would become the cradle of life. Evidence from zircon crystals, tiny, nearly indestructible minerals found in ancient rocks, confirms that liquid water existed at this time, making Earth's oceans far older than once thought. With oceans in place, the most extraordinary transformation was set to unfold, the emergence of life itself. In these mineral-rich waters, fueled by volcanic energy and lightning storms, the first organic molecules began to take shape, setting the stage for the earliest forms of microbial life. What began as a molten wasteland was now a water-covered planet, ready for the dawn of life. But how did life begin? And what were the first creatures to call this world home? That's where the next chapter of Earth's story begins.